promise of AI is not doing a little bit of spot work, all right? Hey, I can make copy. It's like, all right, good for you, man. Can you actually make the book for me? In a foundation lab, there is no product or research. The secret to building a great company in this space is to just treat them as one. And foundation labs are probably the blueprint of companies of the future.
What is your definition of a world model? Thank you so much for joining us. I'm Finn. I'm one of the partners here at South Park Commons. For those who don't know, South Park Commons is a community of technologists who are exploring new ideas, technologies, companies at the earliest stages. Very pleased to have Amit Jain, the founder and CEO of Luma Labs, here today. Amit, we met probably 5 years ago or so. When you joined South Park Commons, you had just left Apple and you were starting to explore neural radiance fields, kind of new area at the time. Over 5 years, a lot has changed. You are now one of the companies leading the way in visual intelligence, last valued close to $4 billion, and doing really, really amazing work with some of the new models that you've released. I would like to start by maybe just going back to the beginning. Tell us a little bit more about your initial exploration in NeRFs. What got you interested in that area coming out of Apple, and how did that kind of end up shaping some of what Luma has become over the years?
Thanks for having me, and thanks for coming, everyone. So, at Apple, we were working on, when I joined, we were working on the LiDAR sensor, and my job was basically the quantum optics for that sensor, and figuring out, right, what the physical world looks like from a beam of light. But the second part of my career there was building personas for Vision Pro, which if you don't know, they're the 3D photorealistic humans you can have a FaceTime call with. The human is not artificial. It could be your mom on the other side of the world, and you're sitting here. Both of you are wearing Vision Pro.
Not an AI companion.
Exactly, not an AI companion. That's not in Apple's DNA. That was a really, really difficult project because, if you think about it from 2018 to 2021 era, right? Meta shipped, if you know, the avatars without legs, most famously, if anyone of you are keeping track of that in Metaverse. We shipped photorealistic humans with real hair and facial expressions and glasses and everything like that you capture by looking at Vision Pro and just, swiping this way. So, very different world. And so in that process, I got to learn a lot about visual understanding, visual intelligence, generation, right? As a problem. We started to work on that in 2019. Actually, the work was going on for a while, actually, before that as well. But I joined that in 2019. And around that time, so 2020, was when Matt published the NeRF paper. Actually, it was in 21, but we had got some access to it early on and things like that. DALL-E came out in, if I'm not wrong, Christmas time of 2020 as well. So you were starting to see that, language models were working. Image models are, kind of thing, because you can make images with transformers now, and you can do 3D with transformers now. So the thinking was, my background is in, so just so you might want to know, because otherwise it would not make too much sense. I learned programming when I was about 12 years old, mostly to do physical simulations. So my goal was to become a physicist. And learning physics by running simulations is the most common thing physicists do. So being able to do just simple simulations, being able to do kinematic simulations, being able to do simulations for electromagnetism, all these kind of things. That's what I learned programming about. And I've been doing that for a very long time, even at that time. So the thinking was, hey, if it's working for language, if it's working for image, if it's working for video, not at the time, sorry. But if it's working for all these things, what prevents it from working for literally every signal of the physical world? And so we might be able to train a physical simulator, right? A thing that can model the world. A thing can actually do that. So that was the initial thinking. And NeRF looked like the closest thing that was a practical implementation at that time. So we started exploring that, right? That's when you met.
Yeah, and the first product that you released was kind of just a 3D capture app, right? Why was that the right place to start? And then obviously you have moved on from that to grander things, and we can talk about that too, but I'm curious why that was the first thing you started with.
In consumer, right, if you don't think about distribution, you're kind of dead. In ML, if you don't think about data, you're dead. So when we started on the 3D path, we're at the time we believed that that might be sufficient. We didn't think it was possibly sufficient, but we thought it might be sufficient. But then the question is there is no 3D data. right? Where is 3D data? There's no YouTube of 3D. There's no Wikipedia of 3D. So how do you get that data? Even if you had 3D models, but that is not 3D world. That is not dynamics, all these kind of things. So the most immediate action was, all right, release something that people would love to use and would be free, and that would give us a large scale of data over which we can bootstrap. We still didn't know what scale of data you really needed, right? Was it 1 million? Was it 1 trillion, right? Or somewhere in between. We had no idea. Nobody did, right? Because these kind of scaling laws are only now becoming apparent. Even in multimodality, the scaling laws don't exist. So that was a first step, and it had commercial value as well. So it was not a terrible step, but that was the first step. Yeah.
And then following that, you worked on a couple of different products, but the one that really I think put you on the map was also the release of Dream Machine as you started to kind of move into video. And maybe some of the 3D capture was just data collection as well. And so this was kind of on your roadmap from the get-go. Was that a pivot? Was that something that you just saw as kind of the next step in a progression towards some future state of the world models, or we can get into that later. I'm curious kind of how did that start to emerge from your research as the next product?
It wasn't really product bet. Right, it was a research. So Luma is a fundamentally research company. We do research, we build products, and we do deploy them. So the guiding principle for the company is 1, multimodal AGI, and 2, joint end-to-end optimization. The only way AI systems will work and be able to do meaningful things in the world is if you do top to bottom optimization. So products are really useful for that, in addition to being very good for commercialization and revenue and all these things that come out of it. But those were early days, and we were still figuring out. So the story of video is something like this. In 24, when H100s came out, right? H100s had 96 gig of VRAM on the card, but more importantly, H100s had 800 gigabits per second of interconnect between each card. When we started to see that as the roadmap, it kind of started to become obvious that all right, and not obvious actually at that time, it was this might be enough bandwidth to move not just text and not just small amount of 3D visual data. It might be enough bandwidth to move images and videos, right? Image models at the time were having a moment with stable diffusion and all these kind of things, but image models are like candy to train, really. Today we train 8, 12, 14 billion parameter image model as a test, right? That's a unit test for us actually at this point. But that H100 architecture was because so I don't know if you know much about the history of AI compute. Before A100s, we had V100s, and before V100s, we had K80s, right? K80s were ridiculous, but at that time, they were the biggest deal in the late 2020s. Late 2018, something like that. A100 was this Frankenstein of an architecture. It was not actually designed for AI. It was never designed for training, the Ampere architecture. But then NVIDIA basically jettisoned all the rendering cores out of it and basically maximized the number of CUDA cores that you can have on this device, or tensor cores actually. Tensor and CUDA cores are a little bit overlapping here. And that was the first training chip, first AI chip, but it was extremely inefficient compared to today's chips, right? H100 was Hopper was the first architecture that was designed for AI, for running training, for running inference. And when that came out, then we were okay, maybe this is not so impossible, right? I actually remember one of people on our team in early 24, we were talking about it. No, I don't think the video will ever be generated by AI because it just seemed so impossible from a systems architecture perspective. It seemed like a pie in the sky problem, but the architecture changed our thinking really. Then we started to build good tokenizers, and Xiaoming, who's our chief scientist today, him, Matthew Tanchik, who is by the way the author of NERF. Xiaoming is the author of DDIM, denoising diffusion implicit models, which is sort of the backbone of all of these image and video models today. He joined our team. Xiaoming was leading image and video models at NVIDIA at that time. Matt was obviously finished his PhD from Berkeley, and as the author of NERF and some really other incredible papers, had incredible reputation. So when these people joined our team, we really started to think very seriously about okay, we can actually train video models. And we started training our video model, I think, end of 24. And then we launched it in March of 25.
You said something there, which is that at the time, before maybe they joined the team, it felt like, being able to generate a video, was something that was totally non-obvious. I think a lot of people feel the same way right now when they think about world models. We were just kind of talking about this, in a roundtable before this, and different folks were kind of sharing what their definition of a world model is. That is maybe still up for debate. Maybe just to start, I'm curious, what is your definition of a world model?
Yeah. I don't think it is my definition of world model. My definition of the world model is the right definition of world model. So currently, nobody actually knows what a world model is. Everybody has random ideas about it, honestly. They are literally random. So some people think hey, if a video model is real time, somehow it is a world model. But what really makes it a world model, right? Just because it is real time? Not really. Because the video model is autoregressive, it's somehow a world model. Not really. Because, even autoregressive world models today are not really autoregressive real video models. They're just self-forced. They're using a technique called self-forcing that allows next frame prediction. But they're not really trained on NTP, which is next token prediction as an objective. Some people think because by training 3D models, like, Gaussian splat models or those kind of things, that somehow makes it a world model. Not really. The definition of world model is actually really, really simple. So what is the definition of an image model? A model that understands the distribution of pixel space, or that understands the distribution of pixels such that it leads to a natural image, and that can generate it. So it understands images and it generates images. That's an image model. A language model is one that understands language really well and generates language. What is a world model? A model that has the understanding of the physical world and is able to generate, or better said, simulate that. That's pretty much it. So that's the definition of a world model. A model that understands and can simulate the physical world. Because it's real time doesn't make it anything, right? It can be slow as hell. You can generate 1 frame per hour, per year. I don't care, right? If it understands the world, it is actually a world model.
Is there then some hurdle for useful world models?
No, if you don't understand the world, you can produce video as fast as you want. It's going to be still trash. It's going to be still a trashy video model, right? The thing you want out of this is, just like a language model has deep understanding of language, not in human terms of understanding, but great understanding of the distribution of what makes intelligent language to the point where we can use them for coding today. A world model is one that understands, I'm always going to use scare quotes around that, laws of physics, causality, time, right? And understands the human logic behind it, which is language. So the shape of a world model looks like a single tower that is jointly able to model language, audio, video, images, physical contacts, all of these things, but as one single signal stream. Right, that's what a real world model would look like. That's what a brain is, right? A brain is able to operate in all of these modalities without having separate towers, without having really different systems and all these kind of things. And it understands the physical world. Do we understand the physical world like in equations? No, not really. I don't think when you're trying to catch a ball, you're actually computing the kinematics of it. Now you intuitively have now gathered that. I think that's what a world model is.
So similar to the early days of your work on video models, do you see kind of the green shoots of potential with world models in your latest work with Uni 1?
Again, so this is becoming an annual tradition for us at this point, which is early in 2025, we started to think about where do video models go from here? So we had just released Ray 2 and Ray 3 was almost done. And now the question was all right, what if this was 10 times bigger? What would happen? That's the question you asked generally, right? You think in logarithms, and if Ray 4 was 10 times larger in compute and parameters, whatever have you, would it be substantially better? Or a categorically different thing, right? The answer wasn't an obvious yes. And we started to see okay, well, what are the problems today? The problems are it really has no understanding of causality and events and prompts you give it. Prompts people have a very bad impression about, but prompts are instructions, right? Instructions you give it it's just so bad at following them. Pretty much all video models, even today, are, right? It produces something that is plausible looking, but nobody would call it a simulation. And nothing we could do to change it by just scaling that over 10x. So we started to think, okay, what is actually the limitation here? There was a lot of work that happened at Luma on compression. First, we thought maybe the problem is that it's not fast enough, and hence we can't make it big enough. So if we made it really, really fast, we can scale it to a large parameter size and it would go. Then we thought about MOEs, all these kind of things. But ultimately, we landed on basically this idea that what the problem is? It just only understands video. And that prevents it from actually doing anything useful. It can produce some clips, but that is about it. It can't do end-to-end work with it. Like, you can't make a movie with it. Why can't you make a movie with it? It's not because it generates 5-second clips. It's because it has no idea who a character is. That thing just looks like a blob of pixels to it. So how do you give it an idea? Like, well, we know that from language models that, like, one, you need to scale them, but two, you need to tie them with human understanding. So we started on this track of unified models, which means, again, one single backbone that has language, which means human interpretation of the universe and the universe. So audio, video, images, all of that, right? Like, video, images, audio are just human measurements of the physical world, because that's how we record them. They're not anything special. They're just signal storage mechanisms. And we started to think about, like, okay, what if, like, there were about 4 trillion tokens of both sides in one single thing? And image models, again, because they're relatively easier to make, we started with Uni 1 as an image model, which is like, it's a unified model with, like, language tower, pretty sizable one, and an image tower that is pretty sizable one, all fused into one single thing. It took us a bit of time, but now it is, like, clear as day that this is the path to go forward, because it allows image models to do things that, like, could never be done before. I mean, a second example of that is the recent GPT model, right? Like, which is also a couple of people from Luma who went to OpenAI, right? And started that effort in December. So I think this is basically the way to think about it. So next video model that we're working on now is, like, unified video model. Will have basically similar characteristics. They're ridiculously hard to train because, language has very different dynamics than continuous signals of images and videos. But this is the way to give these models physical understanding and understanding of human interpretation of what that physics actually means.
So were you training on similar types of tokens for your video models?
Sorry, I don't understand.
Like, did you have image data, audio data involved in those as well?
So image data, yes. Audio tower is not there today, right? So in order to make it a true world model, you need to have, like, a bit more signals. So video and audio will be the next one, basically. And I think once you have video, audio, language, you're about 90% of the way there. You have pretty much everything. I mean, some of you who are in robotics here would make the case you don't have grasping information and all these kind of things, right? And it's true. You don't have smell. That's true. I don't know if robots need smell, a sense of smell. They can just have sensors for some critical things, like, LPG leak, right? Like, and those kind of things, carbon monoxide detection, those kind of things. And I think it will be sufficient. Maybe not in the fullness of time, but, like, initially. But yeah, you need audio, you need video, and you need language. I think those are really, really important. And then everything else that comes after it is helpful, because even if you don't have the exact sense of, like, how much grip strength you should have, you do know from observing videos that, like, hey, something like this can be picked up. But if you see, like, an elephant, like, oh, let's not pick it up, right? It doesn't matter how much strength I put it into that, right? Like, I know my own strength and I kind of understand that. Then you do on-policy training, right? Like, in that world model sense of doing actual pickups, right? Will it crush a lot of cans initially? Yes, but that's okay. You learn very quickly that, like, oh, this is not the pressure I apply here. This is the pressure. This is how humans learn as well. So human brain generally bootstraps from, like, all of these kind of things. And then you go forward with by learning the physical world and length of your arm and the strength of your arm and all these kind of things as babies try to grasp. So that's how we think it will go.
With this unified model, do you think that this eventually replaces language models as well? I'm curious, like, is LLMs just going to be a thing of the past a few years from now, and everything will be structured more as unified models?
It depends on what you mean by that. If you mean that empirically, I think no. If you mean that theoretically, I think yes. So empirically, the considerations are different. When I say empirically, I mean, like, in the field, in deployment, in real usage, right? In real world usage, you want to strike for efficiency a lot more. So I think LLM scaling is now at a point where, like, you just don't see, like, oh, okay. So for instance, the recent Qwen 27B model actually is outperforming a Qwen 289B model, basically, which is ridiculous at this point. So I think, like, we will still continue to use language models quite a bit, but theoretically, a world model which has understanding of language and physics and the world model will strictly be better. It will be more general. It will be able to use in more scenarios. But does that mean you should be using that world model for writing, like, front-end code? Maybe not. right? But if you're making a front end that is really involved and has a lot of visual states and a lot of interactions on it, then yes, you do want to have the world model that can understand the full layout and flow of it and can makes and watch the video of the thing play out and say like, no, this is not very good. Let me edit on it. So use case.
So you might see kind of just systems of models, maybe with a unified model guiding them tailored to a specific application.
Correct. The unified model will replace LLMs as the core, but you might do a tool call to an LLM and ask it hey, can you just code this out because you're more efficient than me?
Tell us a little bit more about Luma Agents. This is a recent release of yours. And I think it kind of goes back to what you were saying earlier, is that there's a lot of value too in just the orchestration and the ability to actually solve, that end-to-end problem for a customer beyond just, having a good model. And there's more than just a model that goes into it. Can you tell us a little bit more about Luma Agents and just how you actually think about making these useful for customers?
Right. So Luma now has a very fast-growing and sprawling business in entertainment, media, advertising. Basically, the use cases for visual models when the accuracy is good enough, where humans think it looks real, but not good enough yet where it's metrically accurate. All right. So for these kind of works, it's actually really useful. Just to give you a sense of that market, by the way, on average, companies spend about 10% of their revenue, not profits, revenue on telling their own stories, right? Every company, but if you're a consumer, you're going to spend about 15 to 20% of your revenue on telling the world about it. If you are a services company, you're going to be somewhere in the 10 to 12% range. And if you are a government or defense or those kind of companies, you're going to spend less, not zero, less. How many of you know about Palantir, right? How many of you know about Northrop Grumman? You have no business knowing about Northrop Grumman because none of us are going buying jets, on Sundays at IKEA. But we know about Northrop Grumman because, well, at the end of the day, the dollars come from our funds and from our tax, right? So every company needs to be known in the world. So it's a very big business. So if you have a stock market that is trading at 30 trillion, right? About 3 trillion of that value is actually going towards telling that story, media and advertising. So, but the thing is and this doesn't apply just to our business, it applies to everything. Promise of AI is not doing a little bit of spot work, all right? Hey, I can make copy. It's all right, good for you, man. Can you actually make the book for me fully, right? Can you actually just go talk to the customer? Hey, I can make a little bit of, image for you or video for you. It's who cares, right? Can you actually do the full end-to-end, movie, or can you do a campaign? In 2024, 2025, we struggled with this a lot because, agents weren't really there and LLMs weren't really good enough for that. Our models were also really not good enough to do long horizon tasks. But we just actually announced a full production on Prime Video with Sir Ben Kingsley. It's a TV show where the production budget is $4 million an episode. And it has Sir Ben Kingsley. It's called Moses, right? And now we're at a place where it is about 90% produced with Luma Agents. And it was never possible to do before that. So what is that? So it's a product that allows you to do large-scale end-to-end production in visual world. So if you are a company that is selling a product online, it can actually help you produce very large-scale assets in every language, for every geography, for every location, right? And it can interpret a huge amount of things. We use LLMs as well and those kind of things. But the big gap was, in order to make agents, you need two things. The generation part, right? The thing that does the task, and the understanding part. Coding agents didn't get good enough until models got good enough to understand the code they were writing at reading large volumes of code and running it, right? Until you do that, you don't know you made a mistake and you can't fix it. And then the person who is at the other end is now left to hold the bag and understand what you did and where you made a mistake. So we had to build really elaborate systems to be able to understand the work that these models are doing, right? So understanding and then generation. So Luma Agents now is the flagship product for Luma. And it's also actually really, really interesting for another reason. So first of all, it's really interesting because it's really valuable to our customers and to a large population in the world. There's 120 million, by the way, if you don't know, visual artists in the world, people who are doing creative work. That is about 2 times to 3 times the number of coders in the world. Massive part of the economy. Second, it's really valuable because now we have a end-to-end optimizable loop. Every interaction and task that someone is doing in Luma Agents is then used to train the agents, is then used to train the models. This is the only way. So we can bootstrap on the internet, but that's the best we can do, right? We can't actually do the final end-to-end problem because nothing on the internet has the data for how you got to that artifact, right? You can see the movie, right? But you don't know how the movie was made. And here we come into the same problems as robotics, same problems as biology, same problems as literally everything in coding and whatever have you. We're like, how did you get to it? And if you want to have agents that can do end-to-end work, they need to know how you get to it. What actions do you do? How do you iterate on it? All these kind of problems. And now there's this really incredible flywheel where we get to see some of the best creatives in the world using them and making really, really great things. And then that improves our models. That improves the agents further. Now the people take it take it even further. That gives us even more intelligent data. And then that's how you get to a system that is like Cloud Code, where just every iteration is able to do many, 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 many more things. And the goal of Luma Agents is end-to-end multimodal or creative work.
I think maybe a week or two ago, we hosted a demo night at SPC, and one of your forward deployed creatives came by and gave a demo here. I'm curious, tell us a little bit more about that program and why you spun it up, and maybe how that also plays back into a similar loop of creating real end customer value and making sure these models are actually solving their problems.
Again, Luma is a deeply research-focused company, and the prime directive is end-to-end optimization, or this optimization loop. FDCs, FDEs, whatever you want to call it, FDCs is a term we invented for creative people because they're not really engineers. So FDCs, one, help our customers actually, deploy these really, really powerful systems into their organizations, which is not a given because, organizations are very complex organisms, especially when you work in enterprise. You're always amazed by the level of complexity that is in any workflow, really, especially if that workflow is critical to their business, right? So if you think about a customer Coke for a second, you might think okay, it's Coca-Cola. Well, one, the sugar water is actually really special and incredible that we can't put it down. But two, Coke is their business is actually two things, right? Like selling Coke, but to the brand of Coke. Coke doesn't make new Cokes every year because, that's not a good thing. We learned from New Coke, if anybody know what I mean. But Coke is a massive brand in the world, right? The second largest only after Apple. And they spend about $2.5 billion a year on content, right? On producing every image that you and I see and subconsciously make us think about the drink, and then we go drink it. It's such an incredible operation. It's driven by weather, right? It's driven by where you are, all of these kind of things. And once you start to learn the details of it, every organization is very, very complex, especially if they're successful, because they didn't get to be successful by doing baseline stuff. They got to be successful because they just really goddamn honed in on that. And so when you're trying to sell them a product or when you're trying to solve a problem for them, you need to master that complexity. And as a technology company, right, how do you do that? How do you do for every single customer you have? You have this forward deployed motion that obviously Palantir, pioneered because they had to go in government institutions, which are the epitome of complexity if I have ever seen anything. So these forward deployed creatives help our customers by understanding what they're trying to achieve. And then one, helping them with our products. And then second, tailoring the product to what they need it to be. And two, they help our research teams understand these things and create these optimization loops that literally actually go directly to our model in the training process, in the data, in deciding what features the next model will have, in deciding if you need to really scale the size of the model, whatever have you. So extremely valuable.
I think everyone here who's, probably with ChatGPT or, with coding agents has felt that magic moment. What do those magic moments look like for your customers in the visual and creative domains?
Yeah. So actually, I'll tell you a couple of things. We were at this gaming company, Savvy Games, that makes Monopoly Go and huge number of mobile games that you guys might actually love and play a lot. So we were talking to them and they were talking to us about hey, they're doing this thing with Avengers, where they will have characters from Avengers in their games. Yeah. And then creating every single one of these takes months and months of work. And I was just sitting there, they were talking how they were talking, and then I downloaded some of those images from the internet, and I asked it hey, look up every single Marvel character and produce a campaign that can be done in 16 countries, with different languages. And by the time we had in about 30 minutes or so, I was not really paying attention to the board that is the product we have. It had produced something really incredible actually, and we were just oh, let me plug this in, and we were showing it to them. And it was actually ridiculous for them to even imagine, because they were like, oh yeah, we thought that AI could be faster, all these kind of things. But when you actually see it in practice, that is actually ridiculous, right? The second one is this Ben Kingsley production now. So I was with James Cameron and Jon Favreau in this thing in LA. It's actually the Academy of Arts. Anyway, so this was a long-winded conversation about AI in Hollywood and AI in movie production and studios and all these kind of things. And where can we use it? We can use it for this tool, this tool, this tool. But everyone has a very theoretical idea. So when we started to show okay, look, this is how they act, and in about 5 minutes, there's a full production loop. A thing that would have taken 6 months before, right? A full production loop from shooting to editing to changing the whole set and then being able to produce the thing. That blows people's minds, and it's not really easy to blow James Cameron's mind because he's the director of blowing everyone's minds, really. So I think that was actually a really powerful moment for me. That even people who you would imagine are pretty blown can be actually you can blow their minds quite a lot. So I think these are the kind of magic moments.
That's amazing. Those are some great stories. I'm curious, obviously you guys are blowing people's minds kind of in, large enterprises. You've had a lot of, individual creators using the products in the past too. There was obviously a pretty big wind down of a consumer video kind of a visual kind of effort recently with Sora. I'm curious, where do you see these models kind of being most useful? Is it enterprise? Is it individual creators? Is it consumer again in the future? I'm just curious how you think about that as a founder.
I mean, we have had efficient video models for a very long time, and we talked in our teams many, many, many times about building a generative social network or something like that. But the problem we always would come back to, and if you guys know our teammates, you should ask them, we talked about this in 25 and 24, 25, all of those times. But the problem was what makes a video interesting has almost nothing to do with whether it was generated or not, right? So Sora had, when it launched, most of you probably had the same moment where it was one, it was really interesting immediately, right? And you're like, oh, this is generative video, and video can be generated. You scrolled for maybe a day. If you're really dedicated, some people who are in our teams, they scroll for 2 days, 3 days, 5 days, right? But then it's okay, now what, right? And so you saw that in Sora's usage graphs and retention graphs, all these kind of things, because the problem is that a video is not interesting because it's generated. A video is not interesting because it's CGI. There's almost nothing to do with why it is interesting. Some of the most interesting videos on the internet are the lowest resolution, right? The worst kind. But they are interesting because what's happening in them. Until we solve intelligence in video, a network like Sora is pointless because, you need these models to understand humor. You need these models to understand context. You need these models to understand your context. A video that might be interesting to you, I might find what is this? I have no idea what you're looking at, right? Because context is local, right? Humor is local. Something we might find funny in San Francisco, people in Miami what the hell are you talking about, right? I can make a joke about MOE and you guys might laugh. And in Miami, I was this is a weirdo.
They made an entire TV show about it.
Exactly.
Silicon Valley.
And I hear there's a new one coming out. It's not called Silicon Valley. I hear there's a new one. Anyway, it doesn't matter. I forget the name now. So it's really context, and that is all intelligence, really. Being able to tell a joke that the other person might find funny requires understanding the state of that person, right? Requires understanding the environment they're in, the local context, all of these kind of things. So we didn't launch a Sora-like thing primarily for that reason, because we just didn't find it interesting, right? The videos that it was generating, and I think that's what the world found it too. So consumer, by definition, consumers don't generate or create. Consumers consume. Creators create. So until we get to the point where the creator is the computer and the models are intelligent enough, unified models we're building, you're not at a point where consumers will want to really create out of the necessity of their heart, right? My mom doesn't really create images, right? She might make a meme here or there, but she's not going to pay for it. On the other hand, enterprises, and by the way, the businesses, enterprises, they are responsible for 99% of the pixels on our screens every single day. By that, I don't mean just the largest companies in the world. a TikTok account that is doing well, 100,000 followers, right, ends up becoming a business. Very quickly, they're going to have an agent, they're going to have an editor, and they're going to have real revenue, really. Actually, you can generate a lot of revenue this way. So they're going to end up becoming a business, and they're going to have a proper operation. They're going to go for the best tools they can find, better than the guy next door. So businesses are currently our biggest customers, and I think that is very obvious reasons for that.
Coming back to what you said earlier is you kind of do these deployments, you learn from what your customers are doing, you feed that kind of back into research. And it goes back to something we were talking about a few weeks ago that stuck with me, which is you just said, product and research are becoming inherently more coupled. I'm curious what that looks like at Luma day to day, as you kind of feed this back into your product learnings, kind of back into research, how you do that, maybe just in practice day to day, and then what that kind of enables. I think one thing that has really impressed me about Luma is that you actually ship, and you ship with a very high velocity. And I'm just curious, can you talk us a little bit more about just kind of those learning feedback loops and kind of how you see these being coupled?
In a foundation lab, there is no product or research. Research produces the product, and product works in research. It's all in the same thing. And foundation labs are probably the blueprint of companies of the future, because of the way our economics are structured, right? We literally target every product that we can make. It costs us barely 1% of our balance sheet to make a whole new product in a whole new domain, because our economics are not dictated by the products we make, by the software we make, but by the compute and by the research we do. At the end of the day, product and research are really the same thing. Practically, does it mean we have a product team that is different from research team? Yes. But that's like having the same thing as in a product organization, you have a growth team and you have a product growth team or growth engineering team, sorry, and you have a design team and those kind of things, right? There's just part of the same ecosystem and the same team. How we think about the product is deeply tied to our model's capabilities, right? We can wish for making a product, but if the models don't deliver on it, then it's too bad. A lot of people then try to build harnesses and complex systems and things like that, and they will spend 6 months optimizing that system, right? We don't do that, right? If it doesn't do that today, too bad, right? Next iteration of the model will do it. It is just data for us in what the next iteration of the model should be able to do. A lot of people, we have seen, who might have spent 6 months, 8 months trying to optimize this one problem to solve one vertical thing. For us, that is basically a 2-week, 3-week long data collection job, right? Where we're oh, all right, it doesn't do that today. Let's gather the data and we'll put this in the next .x training run, or we'll put it in the next pre-training run if it really requires that level of training or requires that level of compute. Sorry. So tasks, the way we think about them. So first of all, we don't think about verticals. We think about professions, right? Which professions we can help, or which kind of people we can help. Second, we don't think about in terms of okay, what kind of spaghetti we can put together to make a product, but rather what is the base model capability and how can we make the thinnest possible product? And of course, it never ends up being so thin. It ends up being a little bit fat. And then the next model's job is to reduce the fatness to make it really, really thin. And the product model just handles it. And then we build a little bit more thickness on top of it to solve a little bit more problems on the, it's this iterative loop of product and model and product and model and product and model. This also really works really, really well for customers, because see, what customers are looking for is end-to-end solutions to their problem, not promises of solutions to their problem. They don't want a narrow solution that okay, well, it does this. Fine, some people might buy it. But at the end of the day, they're looking for, how do I do this film production? How do I do this marketing? How do I do this this kind of thing? So when they're doing that, they want generalist systems, because let's think about marketing. You guys might not think about marketing a lot. I didn't used to either. I'm a physicist by education, but everything that humans are deeply involved in end up becoming an AGI problem. Because think about what does it take to do marketing? And why is it so damn hard? If you're founders and if you're here and you don't have the gene of marketing, I don't, then it's a really, really, really hard problem, right? You need to understand the environment you're in. You need to understand what will resonate. You need to, it's not the final asset you produce. No, it's a problem of communicating with the world, right? It's a problem of what would the world respond to? It's a really hard problem. And when you're trying to solve that problem, right? Like, the models cannot just be, hey, I'm gonna make a good image model. So you need these generalist systems. So if when you build products that are like just like thin stacks on top of like somebody else's models, they really fall apart very quickly. As you're seeing now, like, the iteration of the velocity of model improvements is increasing because again, the infrastructure is getting better and better and better. Every new model, we build better infrastructure and so on and so forth. So product and research in foundation labs are not two different things. They are jointly optimized. And the secret to building a great company in this space is to just treat them as one and like, unified system.
Amazing. Well, Amit, congratulations on all the success of Luma. It's been an amazing journey so far, and you're working on some really exciting new stuff, which I'm sure we'll all see here in the coming months and years. Thank you for coming back to SPC and appreciate you doing this. Let's give you a round of applause.
Awesome. Thank you for having me.